All right. Assalamualaikum warahmatullahi wabarakatuh. Good, very morning to ladies and gentlemen. All right. So I hope that you can hear me. All right. So now, let's we continue. Please scan your QR code. Okay. How are you? Stay safe. All right. So make sure that we can continue the subject, okay, with our session, okay. All right. Good morning, Erin. Good morning, Pa. Okay. Good morning, Muhammad, Arif, and then Siti Noor, Purani. Good morning, Z Jinkyong, Nurul, and Nurul Zara. Good morning, Siti Asha. Good morning, Noor Nabiha. Good morning, and the rest. Okay, please register at the YouTube channel. Okay, for if you want to ask a question and so on. Let's we continue. Okay, our class today. Okay, we before that, I love to do some revision. Okay, come on, if I can share screen with you. All right, I share screen. Mhm. Okay, all right. We learned already about the um, Simpsons method. Okay, Simpsons method, the original Simpsons method, and then the composite system method. So the way to prove the Simpson method, okay, is based on the any odd and even numbers. Okay, let's we go here. Okay, let's I share screen here. If I can continue, okay, with this one. Okay, this one is example of the trapezoidal rule. We go to the Simpsons rule. Alright. Okay. Okay. Based on this one, okay, you can see here. Okay, I want to focus this one. Okay, the Simpsons rule. All right. So we develop the Simpsons rule. Okay, composite Simpsons rule. Okay, by using this formula. All right. Um, 4 times F1, F2, F3 up to the odd value, and then the even number. Okay, we have a 2 times for the Simpsons rule. Okay, you go to page numerical method. Okay, the formula of the Simpsons rule, composite Simpsons rule, is based on the 4 times odd value for Fi and even value for Fi. Okay, even value F2, F4, F3, F6, F8 should be times by 2 and then 4 times F1. All right, so now we learned already, okay, last week. All right, so this is the formula. This is the formula for the Simpsons rule, composite Simpsons rule. 4 times Fi, I is a odd number. 2 times summation Fi, I is a even number. Okay, so now for this time, okay, I want you to continue with the sum example. Let's we go to the sum example. All right, okay, I share screen. Let's I share screen. For the next is Simpsons rule, okay, with the example. Okay, now as we go to the Simpsons rule with the example. All right. Okay. This is I want to explain. Okay, I sent already the video to your group. Okay. Um, wow. All right. So we want to explain the example of Simpsons rule. Okay, we know the formula of Simpsons rule. Okay, come on. We go to page. Let's we go to page. Okay, I stop here first. Okay, we go to page 142. Okay, go to the page 152, and then we go to one of the example. Okay, we find one of the example. Let's we go to the example here. Okay, we know the formula of the Simpsons rule is a h over 3 f naught plus fn plus 4 times f. F is an odd number, and then times 2. 2 is a even number. All right. So that is a formula for the composite Simpsons rule. No need to prove, but we know how to use it. All right. So composite Simpsons rule divide the value the interval into two, okay, sub-interval. That's why they create odd and even. So the question here is we want to find summation the integral between 1 to 4 x divided by x squared plus 1. This is your fx, all right? And then using a Simpson's rule where h is a 0.25, when you know h is 0.25, the n is a 4 minus 1 divided by h 0.25, all right? So you know what is the value of n now, all right? And then this is not involve iteration, but they involve every point, okay? X naught, x1, x2, up to xn. Okay, so now let's solve this problem, okay? The summation of x divided by x squared dx. All right, so now we learn from the formula of Simpson's rule, okay? H is a 0.25, n is a b minus a divided by h. 4 minus 1 divided by 0.25. So the answer is, okay, how many? 12. You have a 12 subdomain, not 12 iteration, but you have a 12 section or sub-interval or segment, okay, it's 12 segment, all right? So in this case, please use your calculator to input the value x divided by x squared plus 1. This is your fx. Use your calculator, all right? Set your x divided by x squared plus 1 in your calculator. Press mode fix 4 because we're using 4 decimal. Remember the formula of the composite Simpson's rule, h divided by 3, a plus 4b plus 2c. What is a b? Summation of fi, I is an odd. What is c? C is a summation of fi, I is a even. So this you remember, okay? So the difference between trapezoidal, they divide the data into one sub-interval, but here you divide into two sub-interval, all right? So they created, okay, between A, B, and C. A is a F naught plus F12, Fn. And then B is a summation of the Fi, okay, Xi is an odd value. And then C is a summation of the FSI, I is an even value. All right. Odd value, for example, 1, F1 plus F3 plus F6 plus F11. Okay. C is an even number. Okay. F2 plus F4 plus F6 plus F8 plus F10. All right. So try to divide into 3 columns. F naught plus Fn, I is a odd and I is even, all right, for F. And then get the summation. So in this case, you need to use your calculator and plus 1 by 1, which is odd and what is even, all right. So this one you need to use your calculator to find every Fi and then divide odd in even for Simpson method, and then you can get the value. All right. H is what? 0.25 given in the question. All right. So put all the value. F naught plus F12 is A is a 1.6772. F I is odd. Okay, is 5.4249, and Fi times 2 for even number. F2 plus F4 plus F8 plus F10, all right, is a 4.5652. So the integral for x divided by x squared plus 1 is a 2.7089. All right. So this is a formula you need to remember about the 3/8 Simpson's rule. All right. So now my question here. Okay, can you prepare? Can you answer my question? Okay. Hmm, how many column to find, all right, composite Simpsons rule? So how many column that you want to create to find the Simpsons rule? If you want to use Simpsons rule, all right. So now the second question, okay, my first question, how many column, right? Okay, this is my question. How many column that you want to create to find a solution for finding the value of integral between a and b for fx dx? Okay, how many column? Okay, if you want to use a Simpsons rule. My question, the next is how many column? How many column you want to create? Okay, to find the integral using composite trapezoidal rule. This one is another question. Okay, how many column that you need to create to find the integral between a and b for fx using trapezoidal rule? Okay, trapezoidal rule. So this is my question. All right. So this is two questions. For the Simpsons rule, how many column? All right. X, Y, okay, Fx, F naught and Fn, one column, and then odd value and even value of F. All right. And then use the formula H over H divided by 3, and then A plus 4B plus 2C. All right. 4B plus 2C. B is a summation, for F is even or odd, and then 2 is a summation for C. C is a summation for F. I is a even. All right. So good. 5. So how about the trapezoidal rule? Okay. Trapezoidal rule. Okay. Trapezoidal rules just only Fn and F naught. All right. And Fn and F naught, and then the rest is all the value without F naught and Fn. All right. So only 4. Okay. Only 4. You can go to the page. Okay. Go to page untuk trapezoidal rule. Okay. How many column you want to create? Okay. Where is the trapezoidal rule? Chapter 6. Okay. Trapezoidal rule. Okay. You go to page 137. There's only 3 column. Okay. There are only 1, 2, 3. Yes, 4 column. Okay. The answer is 4 column. For the composite trapezoidal rule, you need to create 5 column. All right. So this is an example. Okay, nowadays, okay, we want to find a very accurate Simpsons rule by using the Newton forward, okay, by increasing the order. All right. So now we increase the order. Okay, I close here. I want to increase the order of Newton forward different interpolation formula. Okay, I want to create the order. Okay, I want to increase the order because we want to make sure that this method can be improved in terms of the accuracy. So we call other method as a 3/8 rule. So in 3/8 rule, we divide the column, okay, for A and B into 3 column. Means that there is X0, X1, X2, and X3. We divide the region, the area into 3 column, all right, by using the 3 order of the Newton forward different formula. Okay, so before this, okay, for Simpsons rule, composite Simpsons rule is based on the 2 column. But here we want to divide into 3 column. Okay, we call as a Simpsons 3/8 rule. All right. So when we call about the order tree, we name this one as a cubic polynomial P3x. Okay, so meaning that we extend the Newton forward different interpolation formula, okay, to the order tree, 3. All right. Before this, we just focus order 2. Now we order 3. So how to get order 3? P3x is a f naught plus r delta f naught plus r minus 1 divided by 2 factorial delta squared f naught plus r minus 1 r minus 2 divided by 3 factorial. So we have 3 types of f1, f2, f3, and then there are 3 columns, okay, x1, x2, and x3. All right, so we partition the area of y equal to fx into 3 partitions. Okay, what's that? f1, f2, and f3. And then the graph is a curve because cubic is a curve. So that is a Newton forward difference formula we use to apply to get the Simpsons 3/8 rule. Simpsons 2/8 rule. So meanings that, okay, there is a coefficient 3 for this term. Okay, every 3, okay, 3, 6, 9, there is another column. And then other column is not included in the coefficient 3, or meanings that the safety girl divided by 3, factor 3. All right, so the other column. So also we are develop 5 column in solve the problem using Simpsons 3/8. All right, so there is no proven about Simpsons 3/8, how to create, how to prove, but you need to know how to apply composite, okay, Simpsons 3/8 rule. All right, Simpson 3/8 rule and its composite. All right, so now let's move. Okay, let's move to the example. All right, so the formula for the Simpsons 3/8, you can see here. Okay, come on, I see here 3/8h. H is the size of interval times f naught and fn plus 3. Okay, all the fi, which is I is not coefficient of 3, is not the factor 3. For example, f1, f2, f4, f5, f7, f8, f10, f11, f13, which is not coefficient 3, plus 2 times f is a coefficient 3, for example, f3, f6, f9, f12, f15, f18. But we not create the too many, okay, parameters, too many segments for 3/8 Simpsons rule with composite, because it's really make sure that you can answer in 20 minutes. All right, so maybe you can get around 12, okay, segment, or 9 segment, or maybe 6 segment. All right, so now let's go to this example. So how much you need to create a column? F naught and Fn, 1 column. The coefficient 3, 1 column. Non-coefficient 3, 1 column. Fi, okay, Xi, 1 column. Okay, 5 columns. All right. So now we want to go to the example 3.6. Okay, is integral exponent negative x divided by x squared plus 1. All right. So before we go to the example, I love if I can share something feedback from you. Okay. Okay, 3/8 Simpsons rule. Okay, we want to go for the 3/8, okay, Simpsons rule. Okay, Simpsons rule. All right. So, okay, it's come from where? Okay, it's come from where? It's come from where? All right. So why we are using this formula? Okay, is extend from where? Means that I said that extend from which? Okay, which formula? Okay, so it's the 3/8 is extend from the Simpsons rule. However, okay, my question here, all right, from where the Simpsons rules come? Okay, the Simpsons rule 3/8 come. All right, and then is extend from where? Which formula to create the 3/8 Simpsons rule? All right, so now let's wait the answer from you. All right, why we need to use 3/8 Simpsons rule? The next question, why we need to use, okay, 3/8 Simpsons rule? Why? Okay, Simpson rule. Okay, why we need to learn 3/8 Simpsons rule? These are all the questions you need to answer. Okay, I'm waiting your feedback. Okay, come on. Siti Noor, okay, come on. Siti Aisyah, Siti, okay, others, okay, Elia, Faizan, Nasrin, Noor, come on, Pa, Erin, come on, answer my question. Okay, this is all the question that we want to extend composite Simpsons rule to 3/8 Simpsons rule. All right. So from where the formula comes. All right. I don't want you to understand, okay, about the proven, okay, because this is very tough proven. We just give you maybe proven about how to find the composite trapezoidal rule, how to find the composite Simpsons rule. But for 3/8, you know how to apply. All right. So I'm waiting your answer. Okay. Now let's refocus to our subject here. All right. Okay, we want to solve, okay, integral between 1 to 4 exponent negative x set x squared plus 1 is example 6.3. All right, so in this case, you need to know what is n. N is a b minus a divided by h. 4 minus 1 divided by 0.25 is a 12. All right, meaning that in your mind, you have 12 element from x0 up to x12. All right, so meaning that you need to create the value of x0. X0 is 1, x1 is a 1.25, okay, x2 is a 1.5 and so on up to 12. Okay, x12 is 4. All right, so now let's we apply, okay, make sure that you create multiple tree, meaning that factor tree or coefficient tree, multiple tree, because we have 4 columns. All right, so now the f is quite tough now, is exponent negative x divided by x plus 1. It's quite tough. All right, and then the formula that you need remember is there are 2 parts. Okay, 3/8h a plus 3b plus 2c. Okay, what is b is not multiple by 3, and that what is c is all the multiple by 3. All right, so this is a formula that you need to remember. So till today, you know what to remember the formula of trapezoidal rule, and then some more is Simpson's rule with the composite, and now 3/8 Simpson's rule. All right. So this is the F. Okay. Please set the calculator with this F because you want to create for x equal to 0, x equal to 1, x equal to 1.25, x equal to 1.5, and so on. All right. So create the F using your calculator. Press your calculator for decimal places, mode fix 4. All right. Now draw the table into 5 column. All right. And then you need to differentiate between F A, B, and C. A is a F0 plus Fn. B is a value of Fi, which is not multiple by 3. And then another column, the last column is a Fi. I is a multiple by 3. Okay. The value of F multiple by 3. All right. So now let's we go to the column C. This is a column that I want you to create. There is a 3 column F0 plus F12, and then all the value which is not multiple by 3, and then the last is a multiple by 3, for example F3, F6, and F9. All right. So do a summation with these 3 column. A is a F0 plus F12. B is a F1 plus F2 plus F4 plus F5 plus F7 plus F8 plus F10 plus 11. And C is a multiple by 3 or coefficient by 3 or factor by 3 is a F3 plus F6 plus F9. All right. Make set in your mind. Okay. When you do a composite for the Simpsons rule and 3/8 Simpsons rule, you need to divide into 5 columns. All right. So now do a summation F0 plus F12, which is A value. All right. And then not multiple by 3, which is B value times 3, and then 2 plus multiple by 3, okay, F3, F6, and F9. All right. So A is a 0.2645, B is 0.4580 and C is 0.1281. Use your calculator. Okay, please use your calculator. All right. So now, where is your calculator? I want to see your calculator. All right. Please get your calculator. This is my calculator. All right. You need to insert x, negative x divided by exponent negative x divided by x squared plus 1. Use your calculator. Mode fixed form. And then write into 5 column. I is a 0, 1.0, 1.25, 1.5, 1.75. That you create. You create based on the N and H. What is N? Number of subinterval. What is H? Size of interval. Okay, size of interval is 0.25. And then you divide into 3 columns. Okay, F0 plus Fn, F12. Another column is a not multiple by 3. All right, and then the last column is a multiple by 3. Get the value A, B, and C, and then insert in your answer. Very fast. You can do it below than 20 minutes. Okay, below than 20 minutes. All right. So now, let's go to the answer. Okay, come on. All right, this answer from Siti No. They said that Newton forward different interpolation formula. Order 3, degree 3. All right, degree 3. And then Faiza said that Newton forward degree 3. Simpsons degree 2. Composite 3/8 degree 3. Very good. Extend from the Newton divided. Yes, we are using cubic polynomial. Cubic polynomial. S. The pattern is S. Okay. Cubic polynomial. All right. So this one is very good. It's a P3, order 3. For Simpsons, it's order 2. All right. But Simpsons 3/8 over order 3. So meanings that when you increase the order, the result is very good. All right. So how to improve? You said that you need to increase the order. All right, the weaknesses of Simpsons 3/8 is we need to use 3 columns. All right, so these weaknesses, okay, we need to divide, and then that's why we have a 3 column here. Okay, one is for x0 plus fn, and the other one is a not multiple by 3, another one is a multiple by 3. All right, very good. Okay, thank you very much for your feedback. Okay, now come back again. Let's refocus to the lecture. Okay, now, okay, when you insert the value A, B, and C, all right, you insert the value. Please don't forget the value is a 3/8H, A plus 3 times B plus 2 times C. All right, okay, so insert the value. A is 0.2645, B is 0.458, and C is 0.1281. All right. So the answer is put inside here 3/8H. Okay, F0 plus F12 is A plus 3, all the not multiple by 3, and then plus 2, all the F is a multiple by 3. It's a 0.1176. All right. If you have an exact solution, you can compare. It shows that the trapezoidal 3/8 by increasing number of element, number of subinterval, number of partition, the result is much more accurate. All right. So it's very easy. Okay, till today, okay, I want to express here, till today you have how many methods? Okay, trapezoidal rule, basic trapezoidal rule, composite trapezoidal rule, only 4 columns, just to divide between F0 plus Fn, and then the rest is put in the column. All right, and then composite basic Simpsons rule, composite Simpsons rule, basic 3/8 trapezoidal rule, and composite 3/8 Simpsons rule. You have 6 methods. Method. All right. In numerical, you know that when you run the problem, when you want to find the integral, some graph is symmetry. Okay, meaning that on the left part and the right part is symmetry. So my question here, how to find the integral for the graph is symmetry? So my question, come on. Okay, can you answer how to find the integral, okay, the integral for the graph, okay, the graph of fx, okay, is symmetry. Is symmetry. Okay, the graph is symmetry. All right. This is my question. Okay, when because you need to remember again the calculus that you learn. Okay, when the graph is symmetry, so how the way you find the integral? Is this very easy for you? Okay, because the symmetry. All right, because of the symmetry. All right, so this is my question. All right, okay, can you answer the question? Hmm. Okay, I love if I can share with you, okay, to get some ideas. Okay, if I can share with you this graph. Okay, come on, if I can share this graph is a Gaussian. All right. So now, when you see this graph, okay, let's I focus here. Okay, I focus here. When you see this graph, okay, the graph is symmetry. The Gauss too is symmetry. All right, between the left and right. So in this case, okay, there is a method to do the integral where we can convert the domain of the graph between -1 and 1. Between -1 and 1. We can convert the graph into the domain between -1 and 1 because the graph is symmetry. All right. And then there is another condition, okay, to make sure that we can do a fast numerical integration for this type of the integral. Okay, the graph is a symmetry. All right. So can you get the answer? Okay, based on the information about Gaussian quadrature. About Gaussian quadrature. All right. So now let's I share with you the screen. Okay, again. Okay, about the Gaussian quadrature. Okay, when you go to the graph here, okay, about the Gaussian quadrature, okay, you see that the graph is symmetry. Okay, on the left and right is symmetry. Right. So bring the graph to the center between -1 and 1. And then you need to transform, okay, you need to transform the graph, okay, um, into the different domain between -1 and 1, right? So in the Gaussian quadrature, you have the integral between a and b, fx dx, and then we transform, because the graph is symmetry, we transform to the other graph between -1 and 1. We standardize, we dimensionalize the graph for gt dt. So meaning that you transform from x to t, you transform ab to -1 and 1. You try to do the dimensionalize. You create a new dimension between -1 and 1. So when I draw the graph between a and b can be transformed to the domain -1 and 1. So in this case, we call this as a we're applying, okay, Gaussian quadrature. We apply the Gaussian quadrature. So now, okay, I have an answer. Okay, my question here is how to find the integral for the graph of fx symmetry. All right, and then my question, then the next question, okay, why we need to transform, okay, fx, okay, we have a graph between a and b, fx, okay, to gt. Why we need to do another domain to gt? This is my question. All right, so why we need to transform, okay, from fx to gt? Why we need to transform the domain? Okay, why we need to transform the domain is a between a and b, okay, to 1 and 1. Why? Okay, this is my question. All right. Okay. Uh, this is my question. Why we need to transform the domain for the graph, okay, fx between between a and b to negative 1 and 1. So the whole answer for this question, okay, shows that there is another way to do the integral we call as a Gaussian quadrature, where the graph it should be symmetry, all right, and then second we need to transform from the original domain a and b to the dimensional domain, dimensionalized domain, negative 1 and 1. All right. So these are two cases we need to use. All right. So this is my next session is how to do that. So that's question. Okay. We can do two methods. The first is a 2-point Gaussian quadrature. The second is a 3-point Gaussian quadrature. There is no proven, okay, to be asked to you. All right. Just I want you know how to apply. All right. So the next question that you need to apply is how to change the parameter from fx to gt, from a, b to negative 1 and 1. So this is my question. Because the graph is symmetry, you need to have a standard dimension between negative 1 and 1. All right. So the formula to transform is x equal to b minus a t plus b plus a, right, divided by 2. So this is a common, okay, when you do a symmetry graph to the negative 1 and 1, you need to remember b minus at plus b plus a divided by 2. This is the way how we transform a to negative 1 and b to 1. All right, come on. Let's we put inside here when x equal to a, b, x equal to a. Yeah? So a is equal to b minus at plus b plus a divided by 2. All right, so you will get, when you replace x equal to a, you will get t is equal to negative 1. When you replace equation 1, x equal to b, you can get t equal to 1. So please remember, all right, or you can derive this formula, okay, b minus at plus b plus a divided by 2. All right, so now my question here, okay, why we need to use this formula? Okay, because we want to transform from fx to gt and then from domain a, b to negative 1 and 1. All right, what you do now is dimensionalize the function. And then why? Because the graph is symmetry, and then there is a standard way to do the numerical integral. Right? The way you use is a Gaussian quadrature. The way you use is a Gaussian quadrature. All right. So now, okay. Now, since we know the value of t, okay, since we know how to transform from x to t, okay. So the next step is you need to come on, I still repeat again, you need to change dx to dt. Because there is a dx to dt. dx over dt, come on, go to this integral. The integral differentiate with respect to t is a b minus a divided by 2. So dx is a b minus a divided by 2 d divided by 2 dt. So need remember. All right, so this is how we transform, okay, the method. There are three ways. Okay, the first is represent x equal to b minus at plus b plus a divided by 2. Second is transform x to t for every value a and b. The third is do differentiate, okay, dx over dt to get dx equal to b minus a divided by 2 dt. So replace, okay, you replace dx to t. All right, so now, okay, the second question you need to remember is how to apply 2-point Gaussian quadrature and the 3-point Gaussian quadrature. Why we need to do a 3-point? Because we want to get the accurate result. All right, for the, you don't need to prove, but you need to remember for the second point Gauss quadrature, okay, you go to page, okay, come on, if we can stop here, go to your textbook, okay, find the Gauss quadrature in chapter 6, okay. You go to the page, come on, we go to page 6.2, okay. You go to page 6.2, okay, there are two methods, 2-point Gauss quadrature and then 3-point Gauss quadrature, all right. It's come from the way how you do the calculus, okay, integral using calculus for the symmetry domain, all right, please remember, all right. So now let's we continue, okay, focus to page 151, okay. The 2-point Gauss quadrature, okay, the formula is -1 and 1 gt dt is equal to C1 gt1 plus C2 gt2. What is T1 and T2? Is a -1 over C3 plus G positive 1 over C3. Alright, so in this case, you need to remember the formula of G. Okay, you need to create the formula of G. And then second, okay, you need to transform x to dt. Okay, for 3-point Gauss quadrature, okay, is come from the three terms. C1 gt1 plus C2 gt2 plus C3 gt3. So for 2-point, only two terms, but for 3-point, you have three terms. 5 over 9 g negative 3 over 5 plus 8, okay, so there is three terms, yeah, plus 8 over 9 times g naught g0 plus, okay, the second term, and then the last term is 5 over 9 g 5 over 3 over 5 set. So there is a three terms for 3-point Gauss quadrature. All right. Why? Because we want to get a very accurate. You have three terms here. Okay. We can apply using one question. Okay. Let's we find one question. All right. To apply 2-point Gauss quadrature and 3-point Gauss quadrature. All right. So come on, I'm stop here. Okay. I want to ask question here. Okay, the question is what what is the difference between 2-point and 3-point Gauss quadrature? Okay, here's my question. All right, what is the difference between 2-point and 3-point Gauss quadrature? Okay, the difference is a formula. Okay, 2-point Gauss quadrature using two terms. Okay, and then 3-point Gauss quadrature using three terms. It's come from the how you do the integral based on the graph is symmetry. All right. So now this only. There is no proven. There is no how to create the formula. You just know how to use the Gauss quadrature. The weaknesses of Gauss quadrature, if the graph is not symmetry, all right, the graph can be converted to A, B to -1 and 1. All right, the graph is different, it's not fulfill the requirement, we cannot apply Gauss quadrature. Not every integral can be applied Gauss quadrature. Please remember. Okay, please remember. So the answers is the terms. Okay, the terms only. All right. So now let's we continue. Okay. From here, we want to apply the Gauss quadrature 1-point and 2-point. Okay, this is a notes that I give to you. All right, the formula here you need to remember is x equal to b minus at plus b plus a divided by 2 to transform between the domain AB to -1 and 1. All right. Second, you use this graph to find the dx over dt. Okay, is equal to b minus a divided by 2. So you replace dx, okay, equal to b minus a divided by 2 dt. Okay, that is number 3. All right. And then number 4, you just apply 2-point and put a star and 3-point Gauss quadrature. Okay, you just fit in, but you need to find G. You need to find G. What is G? G is a F, B minus AT plus B plus A divided by 2. Alright, so this is a G. dt is a B minus A divided by 2 dt. Alright, so please remember, we are given the formula during the final exam, don't worry, but you need to know the coefficient, the rule, why we apply the Gauss quadrature. Why? Okay, that I told you, there is a specific graph, can be applied Gauss quadrature. There is specific AB where we can apply the Gauss quadrature. All right. Okay. So we are going to have the example after this. We are going to have the example after this. All right. So now, okay, this is a question that you need to remember. Okay, you can go to the exercise. Come on. Okay, go to the exercise. Okay, we can start exercise. Okay, please find the exercise here. Exercise 6, okay, 6.2, exercise 6.1. Okay, you can answer the question, right? Please do that. I'm going to distribute the question. All right, so now I want to share with you, okay, if I can share now, okay, come on, if I can share okay, if I can share here. Here. All right. In your section 2, okay, you are in section 2. All right. Come on, you go to the link that I sent to you. Okay. I can send to you again. Okay. All right. Where is your chat? I send to your chat. Okay. I give you a question. Okay. I send to your chat. All right. I give you a question here. Okay. Let's be focused. Okay. Okay, this is a link. Come on, go to the link. All right, and then go to your Telegram also. You can see I send you the question. All right, to do a revision for chapter 3, chapter 4, chapter 5, chapter 6. All right, why? Because we are going to have a test too. Come on, you go, because I get the question from the past question. Okay, I put in the part to make sure that you can answer and then share with your friend. All right. I'm also want to share with you, which is I'm quite happy because there is a good feedback from your group. Okay, come on, if I can find back my section 2. Yes, section 2 here. All right, Newton divided. Okay, so all of you already answered. Okay, you can share the answer with your friend here. Okay, you can go to the okay, this one. Okay, if I can share with you through the okay, this one will probably share, right? All right, come on, I share. Okay, if I can share screen. Okay, share screen. Here. All right. So now I'm very happy because there is good feedback from you. Okay, go to the top chat. Okay, you can see this is the answer from your friend. Okay, the correct answer at the back of your book. All right, at the back of your book. All right, for the okay, you can get the solution from your friend. Thank you very much. All of them are give a good feedback. Thank you very much. All right, so now I want also to share with you the, if I can share the e-learning. Okay, go to the e-learning. Okay. Okay, we go to the e-learning here. All right. Okay, you okay, scroll down your e-learning. I send you the revision. Okay, I send you the revision. Oh, there is not sharing. I thought I shared. Really? Okay, I think I share. All right, they're sharing. All right. So now go to January to 16 January. Okay, I sent already the example for test 2, final exam, for covering chapter 3, chapter 4, chapter 5, chapter 6 at the e-learning, please go to the e-learning, all right, and then get the solution, get the question and get the answer, how we do the marking, okay, scheme for your answer script, all right. So I'm also sharing you quizzes, okay, come on, if I can go to the quizzes here. All right, open there. Okay, I edit, I show. Okay, go there. You can use a composite Simpsons rule. All right, so this is a quizzes. Okay, please go to the quizzes. Okay, now go to the quizzes. Okay, you click here. Okay, there is a question here. Please answer the question and submit before tonight. Okay, before tonight. All right, so this is a question. Integral between 0 to 4 x exponent to x dx using the composite Simpsons rule. I'm not asking to use 3 over 8 Simpsons rule because I need to check whether this is a suitable method to do 3 over 8 Simpsons rule. But at this moment, I just want you to solve the integral x exponent to x dx using two types of subinterval, okay, which h equal to 2, the n is a 4 minus 0 divided by 2 is equal to 2. Two subinterval. The second is if I decompose, okay, or partition the data into h equal to 1, so n is equal to 4. All right. So please submit through the e-learning, yeah, before 12 tonight. So I print screen. Okay, I print screen. Okay, here. Okay, to make sure that you okay, I print screen. I send to your telegram. Okay, make sure that you can answer this, okay, before 12 tonight, okay, before 12 midnight. All right, so because this is a quiz, I give you a time, go to the telegram. Okay, I send you the place where you can post your answer script. Okay, your answer script. All right. So I think this is for today. So thank you very much for today class. Okay, I giving you the, don't forget to go to the e-learning. Second, I also give you the e-books, e-notes, okay, the video. I send you the video, go to the YouTube, all right? And then the class today, you can also search through the YouTube. All right, I think it's enough. Thank you very much, okay? And then please scan your QR code for today attendance and clarify based on the quizzes at the e-learning. Okay, all right. And then the submission for the revision you can submit before 11 January. Okay, this is different. But for today, you need to send through the e-learning. I'm waiting you at the quizzes e-learning. I'm waiting you at the quizzes e-learning. Bye-bye. Thank you very much. Okay, thank you very much. Go to Padlet. Okay, go to the e-learning. All right. So this is a task for today. All right. If you have any problem, please chat with me. We go for one-to-one tuition. All right. Bye-bye. Thank you.